Hi everyone, welcome to the first topic of your advanced crash course in R, a tidyverse and language perspective. Today we're going to talk about the R environment, data structures, how to create functions, how to manipulate and clean data, as well as an introduction to the tidyverse, a collection of packages within R designed for data science. We'll also do a deeper dive into the basic verbs of dplyr, a package within the tidyverse. The only thing that you'll need beyond this lecture is the topic materials. You'll find this on the course page, and if you download the Topic 1 materials, you'll be able to find the R script and everything you'll need to reproduce the code found here. All right, let's get started.
Hi everyone, welcome to our studio. If you're already super familiar with R, the R environment, and our studio, feel free to skip through the next couple minutes. But right now we're just going to get everyone up to speed who is not familiar with R or our studio. So a little bit about R, and then I'll go through what all of the different components of what we're looking at here. R is a syntax-based language. So unlike SPSS, you type things to actually write code. Though if you're making the jump from SPSS to R, I might recommend R Commander. R Commander will look and feel a lot more similar to SPSS. There are ways to run a t-test just by clicking things. So imagine instead of having code here, it said something like model, and you would click different things in order to run a t-test. So if you are still yearning for this more click-based method, you can use R Commander, but hopefully we'll get you up to speed and you won't feel like you have to. Some important keyboard shortcuts. If you're using a Mac, the way that you'll actually send code from the editor, which is what we have up here, down to the console, is by doing Command Enter. So I can do 1 plus 1 and get 2 down here. If you've never used a statistical language before, you might wonder, why is it coming down here anyways? And basically the reason is because what we have here is we're editing our R script. So you can think of our R script as if it's a Word document. Anytime I make a change, it's going to turn red and I'll have to save it. If I make another change, it'll turn red again. However, unlike Word, where there's only one place to write and edit code, we have this console too. And I can also write things down here. But the big change is that when I do this down here, I don't have to now save my script. This is because you can think about this as almost a whiteboard. Everything you're doing here is going to compute in the same way as if you were to run it up here. So if I now did 1 plus 3, we're going to get the same output. It's going to look exactly the same. The only difference is now it's changed my document. And the reason this is important is because you might find yourself doing a bunch of things in the console and then realizing that it's not saved later in your script. If this happens, you can go to history and basically click on lines of code or multiple lines of code and either push them to the source or push them to the console. So again, you can think about the console as this whiteboard. It's going to disappear after a little bit. And your editor, which is what we have up here, as really the Word document that you're working on, that you're saving. And in order to go between this editor window and the console whiteboard, you can click Control-2 to move from the editor window to the console, or Control-1 to move from the console up to the editor. So like other statistical languages, you can use R with a calculator. I can do 1 plus 1, I can do 2 plus 2, and my results are going down to the console. And you can actually save these calculations as objects by assigning it a name. And when I say assign, I mean we're using this caret and dash to assign something. So we're taking the value of 2 times 2, and we're using this to assign it to something called math. When we do this, we can now call just math, and we see that we've now saved the number 4. But note that R is case sensitive. So if we try and look at math, this won't work. We're going to get an error saying that math is not found. This is because we've saved lowercase math, but not uppercase math. In addition to being case sensitive, R is also picky about its punctuation. So commas are going to be really, really important. I think one of the most frustrating things was realizing early on that I had missed a comma somewhere, or I'd missed a quotation, or an end bracket. So definitely try and be really vigilant about your use of punctuation. And we can see this here because R does not like this curly quote. The word that's in this curly quote is black, but the word that's in this straight quote is green. And the reason it's green is because R is now recognizing that whatever is in this has a different type of meaning. So it's not an object like this math, it's something like a level or a specific character or something that we're trying to pull out of our data. It's also worth noting that you can write over objects, so be really careful when you're naming and renaming. So if we look at math now, we have the value 4. However, if we were to assign 2 times 3 to math, we now have the value 6, and our value of 4 is lost. So be careful and ensure that if you're ever going to write over something, make sure you're calling it a different name. So for example, call it math 2. And this math now is math. And if we call math and math 2, we now have both different values. The great thing about R, though, is that if you do make a mistake, you can really easily run through all of your code again. So just go ahead and rerun whatever lines you've messed up, and everything will be just as you want it. So don't worry too much if you do write over something, just make sure you start from the earliest code and then go down. This also brings up the point that it's really important to write code in a way that's linear. If you were to run R again and your environment happened to be cleared, all of your code is going to be messed up. So try and make sure that you are really running your code in a linear way. Also, I think I mentioned this already, but this is an R script document, which means that R is assuming everything inside this is code. So if you want to add notes for yourself or someone else, make sure you use hashtags. Some other notes on syntax. A lot of people within data science think that there are 2 conventions in terms of how you write your code. The first convention is to use underscore. For example, if you wanted to write new math, you would do something like this. However, the second is this to use a combination of lowercase and uppercase. And if you were to use this convention, you would say something like new math, because typically people start with a lowercase and then every other letter afterwards will be capitalized. So these would be the 2 conventions. And the reason people do this is because your code will tend to look a lot more coherent if you try and adapt one syntax pretty consistently. Okay. Another thing that I'll mention is in all of my R scripts, I use these headers. And what this allows you to do is if you're trying to look through my code later, you can go ahead and click this and skip around to different sections. Let's talk a little bit about updating and installing packages. So you can load packages one of 2 ways, using this library function or this require function. But you'll need to have a package installed in order to load it. So if I were to load library S2, I will get an error. However, if I install the package first using this install packages and then run the same line of code, now this will work. We're not getting any error because I now have this package in my library. And if you ever want to check what packages you have, you can go to this package tab, you can look through, or you can search for specific ones. And now I'm going to see that I can tell that it's both loaded and installed. I can tell that it's installed because it's coming up as one of the packages, and I can tell that it's loaded because there's a little check mark here. If I were to click this, you can see I'm getting this detach package S2, which means that I'm unloading it. It's basically the opposite of using this library. And I can also go ahead and click this, and what you can see happens is I'm getting the exact same line, except rather than me writing library S2, because I clicked on this, R is automatically doing this for me. However, when you're writing code for others, you shouldn't assume that everyone already has a package, because if you send them code and they don't have a package, they're going to get the error messages that we got earlier, namely there's no package called S2. So when you are writing code for others or in your own code, I would recommend using a line of code like this, which both installs the package if it's not already installed, and also requires or loads the package. So this line of code will work for any different package. All you have to do is change S2 with whatever package name you want. You can also uninstall a package with this remove package function. So we can go ahead and do this just to see, and we can see two things. First of all, we're getting something that's telling us, yes, we've removed it. And now if we look in our packages, we can see that it's completely gone. It's not only unloaded, but it's been completely uninstalled. You can also update packages using this update package function. Again, this is really good standard practice if you are sharing code, because there are always changes that happen with packages. And so by updating your packages regularly and updating them, particularly before you share code, you can reduce the potential for errors. And when I say errors, I mean your code not being 100% reproducible because you used code that was based on a different version of the package. Okay, so far we've talked a little bit about R, how to update and install packages, but let's talk about how to import data. So what I've included here is the different functions to import data from different types of documents. So we have CSVs, Excel files, Google spreadsheets, RDA, or from the web. The list goes on. This is mostly a reference for you. I'm not going to go through all of these now. Yes, and if you want to look for more, one thing that's nice with R is if you start typing something, you can see that it calls up a whole list of other options. So this is always something that's helpful. Another thing is if you actually look at if you click on something, you can see all of the different arguments that the function takes. And don't worry about this too much now. I'll go through this with an example later, but this is just helpful if you need to jog your memory about something. Okay, so let's talk more about loading data. All right, let's load in a data set from the internet. We can see that it worked without any errors, but let's try another one. Okay, R is screaming at us. We're getting an error saying that we can't open this file. Now, why isn't this working? Well, it's because we don't have a folder. It's because we don't have a CSV called dummy data in a folder called Kirsten's dummy files. And the reason I purposely included this broken line of code is because I want to show you, I want to break down how we install files. So what we have up until the actual file name is called the path. Now, the path is basically telling your computer where to look for the data, because your computer won't find your data set, for example, dummy data, if it doesn't know where to look. You can think about this if you're looking for your keys and your keys are in the kitchen, but you're looking in your living room. You can look everywhere in your living room, but if the keys aren't there, you're never going to find it. In the same way, if a file is sitting on your desktop, but you haven't told your computer to look in the desktop, it's not going to be able to find the file, even if your file is in your computer. And this is why if we just try and run line 119, where we read in the file with no path, gonna get the same error. So what do? We can use working directories. A working directory is where your computer is looking. You can figure out where your computer is currently looking by using this getWD. This is going to tell me that my computer is currently looking in my 2021 R workshop. However, I know this isn't where the dummy dataset lives. So I know that my dummy dataset lives on my desktop. So in order to change this, I have to set my working directory using setwd to desktop. Now, when I do this, I can go ahead and read my CSV and get no error. So we can tell that I didn't get an error because I now see that test data set now is appearing in my environment. But this is only helpful if we know that this something lives in the desktop. And other people might have different conventions for this, but other ways that you can try and figure out what your path is. But a little trick that I like doing is using import dataset from Excel. And obviously I know that I have a CSV file, but I'll show you why I'm doing this. If I click, if I'm not sure where this COVID deaths data set lives, I can actually go ahead and copy this, click cancel, and then paste it into my document. Now, something that you're gonna need to change is rather than read Excel, you're gonna need to write read CSV. And again, I've included all of the different ways you can import data here. But now I know the path of this document. How do we save data? There are two primary ways, in my opinion, to save data. The first, if you're working with a CSV and want to keep it in a CSV format, you can use just this write CSV format. So the two arguments that this takes is the data frame name. So this is whatever you're using in R. So for example, politeness. And the second is what you want the file to be saved as. So this does not need to be the same thing. You can write anything if you want, but it just needs to have .csv to tell R that it has to be a CSV file. Another way is to use save, and you can save it in other formats beyond a CSV. Importantly, if you want to save your data in a specific place, you can add this path argument. So this might say downloads, this might say a specific folder, but this can be helpful if you want to save all of your data to a subfolder of your working directory, say called new cleaned data or something like that. So let's go ahead and do this. And let's try loading this politeness clean. But before, let's actually clear our workspaces so we can see what happens when we load it in. When we load this, we now see we have something called politeness in our global environment. Now, the reason I'm bringing this up is because we've technically saved it as politeness underscore clean.r data, yet it's coming up in our global environment as politeness. The reason this is because we've saved the data frame politeness. So when you use the save argument, when you're loading something in, you're actually loading whatever that previous name was. So if you want it to actually reflect whatever the file name is, I would recommend renaming it beforehand. And you can do this by just basically creating a new data frame, and you can just copy over everything from politeness into politeness clean, and then swap politeness here with politeness clean. And then you can have a match between the data frame name that's going to shoot into your global environment when you load it and the file name itself. Yes. Okay. And I've included this here too. Great. Okay. Now that we've talked about loading data, installing packages, let's talk about how to work with data. So the first thing I recommend doing is always looking at your data set. So today we'll be talking about this politeness clean. Let's go ahead and make sure this is a real data frame for us. I just look at the data frame. This is a pretty small data set, so I could just actually look at the entire data frame. However, when you have much larger data sets with more variables, you want some shortcuts. And here are the things that I typically do to explore my data. The first is I look at the dimensions of the data. I look at the number of rows and columns to get a sense of how many participants, or it's not always. I look at the number of rows and columns. If you want more than just the metadata, you can use this head, which will show you the first 6 rows of all columns. So the reason that you might want to do this, if you want to just quickly see what are the variables and what is in the variable. So for example, we see that gender has F, so this is different than it being 1, 0, 2, etc. um, which can tell you a little bit something about your data. You can do the same thing with tail. This will show you the last 6 rows of all columns. And something that is really helpful, in my opinion, is looking at the structure of your data. This tells you what kind of variables we have. If you call structures, you can see that we have 5 variables, but in addition to showing a preview of their levels, we also tell what kind of class. This is important later when you are trying to manipulate the data, because you might run into situations where you think you have an integer, like 1, 2, 3, because it's a number. But if it actually has these quotations around it, it means, and I guess it will say it here too, it might actually be a character. And so the reason I said this might be something that you run into as an issue is because if you try and run a mean, for example, on a character, it's going to throw an error because R doesn't know how to divide f from m, or 1 plus divided by 2 if it's a character, because it doesn't know how to divide letters. So knowing the structure, knowing the class of your variables is really important. And the way that you figure out the class of your variables, I'm sure I have this somewhere later, but let's just try class of gender. We can see that we have a character which matches up to what we see here. And finally, we can see the names of our variables, which again, we can already tell by looking at the structure. If we want to call a specific column, we use this $sign. So I can look at the subject column, I could look at the scenario column, and I can also summarize the data by calling a table. So I can look at number of all of the levels in each variable, for example, gender. If I wrap this table inside a prop table, I can look at the proportion, the percentage in each category. If I want to go ahead and tell R to multiply by 100, I can just add that to the outside of this line. And finally, I can look at the levels of a variable by using this levels argument. Okay, and the reason we're getting an error here is because this is not a factor. So when we call levels on something, we are typically using a factor variable. But a shortcut that you can do is actually just add as factor. And now you'll see that the 2 levels are male and female. You can also do the same thing with numeric variables, which becomes kind of helpful. So we can run levels, but the levels are very similar to what you're going to see from a table. So I think running tables is one of the most helpful things you can do when you are cleaning data, especially if you're creating new variables or editing variables. Always call a table before you make edits, and then a table after you make edits. And this will help you spot a lot of errors. Because if you start seeing that you've accidentally turned one label to zeros, and what I mean by that is you've basically deleted them, it's easy to catch that error. In addition to looking at summaries, you can also compute specific metrics about the data. It's pretty intuitive. You can call the mean. And again, we have this very consistent formatting. You have the data frame name followed by the $sign, which is telling me in this polite is clean, I want to look at this scenario variable. You can call it the mean. If you want to show multiple metrics at the same time, you can use this concatenate. So concatenate will come up a bunch of times later on, but essentially what you're doing is you're taking they're down here, the letter C, 2 friends, and you're basically gluing them together with commas. So if I could concatenate A and B just by using commas, and the same way I can concatenate the mean and standard deviation by wrapping them inside this concatenate. When I do this, I see both the mean and standard deviation in one line rather than on 2 separate lines like this. We can also compute specific metrics about the data for a specific group. So for example, we might be interested in the mean scenario for just females.
And the way we do this is by adding what's inside this bracket. So if we were to delete this bracket, it looks exactly like what we're doing before. We have the data frame and the variable. But what we're adding here is we're now adding, again, the same conventions, data frame and variable. And by using these two equal signs, we're telling R, I only want the data from this data frame where gender is equal to female. I could also do something similar, except I could say I want everything where it's not equal to female, and I can use this exclamation point followed by an equal sign to denote is not. So let's do the same thing for men, and we can see we're getting an NA. So why are we getting this NA? For female, we were getting numbers that make sense. One thing we could do to figure this out is go ahead and look at the data itself. You can see that the one thing that's different is we actually have one of the values as an A. And that's why R is not able to compute this mean because it doesn't know how to compute a mean with an NA in it. So what we can do is we can run a very similar line of code, except add this rna.rm equals true argument. And what this is doing is it's telling R to remove the NAs. Another thing that can be helpful if you want to include several different levels is rather than using these two equal signs, you can write in and then use your concatenate to then include them. Again, any you can also just write T if you prefer. And this can save us time if we have lots of different levels that we want to include. To visualize our data, we can call this plot function. In the second topic, we'll talk about ggplot2, which I think produces plots that are a lot more sophisticated. But for now, we can go ahead and use the simple plot function. You can now see that this plot window appeared. It was always there, but before it was not, there was nothing there. Within this plot window, we can zoom it. One thing that's nice is if you actually just use your cursor, hold onto the plot, you can move this and put it directly into any documents or PowerPoints. This is actually something I'm embarrassed to say that I just learned recently. Before I was using export, saving it to my clipboard or as a PDF, but it's much quicker to go ahead and just pull it directly from R because that saves all of the extra steps of having to save it. So once we've gotten a sense of our data, once we've visualized our data, visualizing is really important because it helps you spot outliers, it helps you spot patterns in your data to tell you about what kind of models you want to fit. But once we've done this, we can manipulate our data. So for example, we can create a new variable. And the way that we do this is by just writing, again, data frame, $ variable, but we've actually wrote a new variable name. And for the purpose of this example, we're going to make every level in this new variable called politeness. So now if we look at this variable, we see that everything is called politeness. And if we call our names to look at all of the names in this data frame, we can see that Dataset is now one of them. We can also subset our data. So I can use these brackets to tell R that I want a specific combination of row and columns. In R, the row comes before the comma and the column comes afterwards. So if I run politeness clean, bracket 1, 5, I'm taking the first row and I'm taking the value of the fifth column. So if I do this, I get 213.3. Let's go ahead and check if this is correct. So I wanted the first row of the fifth column, which is frequency. Another thing is if you look at the viewer and scroll over the top of the variable names, you can see the column numbers, which can be helpful. However, I caution against using column
this too much, because if you were to add another variable earlier on in another iteration of your code, it's going to change what 5 might equal to. So just be careful about doing this. We can also subset for a specific column, for example. So again, like I said, it's row, comma, column. So by running this, we can now have something that is just a single column. And the reason that I've added these other steps, so as data frame and call names, is because when I do this, and I'll just go ahead and show you, because we're only having one column, it's turning everything into a vector. And a vector is just a set of elements of the same type. So in this case, they're all characters. And what I'm doing in this next line is I'm turning this back into a data frame. So if I run this, I now see that I have a data frame with one variable, except my column name is now my variable name, because that's what the vector was called. And I can change this by wrapping my vector, or my now data frame, in this call names argument, and then renaming it gender. So now, let's go ahead and write ahead. You can see that I now have my data frame called politeness clean v2, and my column is called gender. If we want to subset multiple columns, we can use this concatenate, which we already talked about, and grab columns 2 through 5, for example. Now you can see that we have everything in the right format without doing all of these extra steps. We can also remove columns. So we can remove columns by, instead of having just the concatenate, we can put a little subtraction sign beforehand. And when we do this, we can see that the gender and frequency columns disappear. Now, another thing you might notice is there were previously 5 variables or 6 variables, and now there are only 2, even though we only have the numbers 2 and 5. This is because I've included, rather than a comma, a colon. And what this does is it allows us to specify a group of columns. So if I go ahead and just look at this, we can see that this 2 through 5 is calling all of the numbers between 2 and 5, all of the integers, sorry. And we can do a very similar thing with rows. So if instead of being after the comma, we call them before the comma, we can see that now we are removing the 2nd through 5th line. And you can see this the far left with the numbering. Okay, so that was a very quick introduction to the basics of using R. We talked about the R environment, how to update and install packages, how to import data, how to make sure that we're importing it properly and saving data. We also talked about working with data in base R. Specifically, we talked about how to explore our data, how to look at summaries of our data, how to visualize our data. Again, topic 2 will really do a deep dive into this. And finally, how to manipulate data by creating new variables and subsetting our data. And now we're going to talk a little bit about using dplyr. So dplyr is a package within the tidyverse. It expects what they call tidy data, which just means that each variable is in its own column, and each observation or case is in its own row. So what we saw with this politeness data frame would be considered long data, because we see that a single subject, like F1, appears multiple times. However, that would not be considered tidy data. That would be long data, and tidy data would be considered wide format. So that's a helpful terminology as you're trying to figure out, how do I Google things? Remember that tidy data or wide data, every single observation is its own row. And the most important thing, in my opinion, about dplyr is that it used types and verbs to transform data. Now, I'm going to go into more depth about what these are in a minute once we jump into the code. But for now, let me just quickly explain what this is. So a pipe is this little funky contraption, it tells R that you're going to manipulate data. And verbs tell R the type of manipulation you're using. So these are a list of some of my favorites, but just to give you a sense of the flavors, mutate creates new variables. We can also rename variables, change ordering, count the number of cases, and I've included both on the course page and also here a cheat sheet that goes through all of the main verbs and how to use them. And I love dplyr for two reasons. First, it follows a very consistent pattern or grammar, which makes it really easy once you've picked it up. And second, you can combine verbs easily using pipes. So the pattern is as follows. You have your data frame, pipe, your verb, whatever your function or variable is. Again, we'll talk about this. And you can keep combining other verbs using more pipes. So this is probably not super clear yet, but let me try and explain using an example. First, let's go ahead and load in our dplyr package. As you can see, we have some warning messages. These are not something to be too worried about, but it is good to be familiar with the objects that are being masked. So what this means is that there is another function within these packages, so within staff and base, that has a similar name. So within dplyr, there's a, for example, function named filter. And this means that R might get a little bit confused about whether you're trying to call filter from this dplyr package or from the R package. And if this does happen, what you can do to get around this is actually tell R what package you want to use. So if I want to use the filter from the dplyr package, I can go ahead and just add dplyr or whatever the package name is, and then 2 sets of colons. And this tells R I want to use filter and I know exactly where I want to use it from. So if you are having issues where your code looks completely right and you're getting some sort of error, I would really strongly recommend just adding that. And I've probably already mentioned this, but I do have an entire document dedicated to I got an error, now what? And this is one of the solutions I mentioned. So follow the specific grammar. You have your data set, you have your pipe, you have your verb, and then you have either a variable or some sort of function. So what we're doing with this select verb is we're just selecting, we're grabbing a single variable from our data set. So if I run this line of code, we can now see that I've only retained this one variable. This can be really helpful if you're trying to slim down a really large data set. Alternatively, you can remove a single variable by adding a subtraction sign right before your variable. So we can run this line of code and now see that everything but the gender variable is retained. Okay, so that's the select verb. Another verb we can use is count. And we can actually, like I said, combine the verbs together. So we might want to select a single variable and then count the number of rows in each level of that variable. You can do this by using, again, select and then using count. So now we have, essentially, this is producing a table. And I think actually this is a little bit redundant again, but just for proof of concept. We can also summarize based on a single variable by using this group by argument. What this group by argument is doing is similar to how earlier we were using those double equal signs to filter for specific cases. This is going to basically tell R, I want you to do some sort of computation on each of my variable levels separately. So in this case, we're going to create the mean of gender based on the individual genders itself. So rather than doing what we've done here and computing the mean for men and then the mean for women, we can actually just use this group by, where did it go, to do this separately. If you want to compute multiple things, you can again just use a comma, and now we have both the mean and standard deviation. If you are like me and don't like looking at the entire computation, you can rename something by choosing a variable name and followed by an equal sign, and this will rename those columns. You can also group by multiple variables. So we can group by both scenario and gender, for example. And now we have, for every scenario and gender combination, we have a mean frequency and also a standard deviation frequency. One thing I will mention is the order in which you group variables matters. So if I were to flip the order and now look at gender, comma, scenario. So let's look here, we see that scenario is the first variable that appears. If I swap this and make gender the first variable, we now have all of the females together and all of the males together. This is important because there might be a reason that you would want to directly compare males and females within scenario or scenarios across gender. We can also rename our variables with this rename verb. Specifically, we have the old variable on the right-hand side and the new variable name on the left-hand side. And if we run this, we can now see, so if we run this, we can now look at our names and check if we did rename our variable to gender. And it's not there. And I've included this to remind you that running these pipes aren't automatically updating your data frames. In order to update your data frames, you need to again assign whatever computation, whatever you're doing with your dplyr verbs to a new data frame. And if you do this, then you can see that now this has been updated. Now, you don't have to assign it every time. Like if you're just interested in computing the means and you're just trying to get a sense of your data, I would actually recommend not saving it to a data frame. Don't clutter your environment if it doesn't have to be. However, just remember that everything you're doing is not going to be represented in your data frame if you're not using this assign. Okay, so now let's get to one of my favorite verbs, mutate. Mutate helps you create new variables. So in this new variable called scenario new, I'm going to take scenario and add 1. And then in order to check my work, I'm going to look at both the scenario and scenario new variables. And when I say check my work, it's because I want to make sure that R is doing what I think it should be doing based on my code. And if I look at this, I see that the first one, scenario, yep, that's 1. If I add 1, it's 2. Now, this is a situation where once I had the variable working, then I would go ahead and assign my variable. But until I was pretty confident that it's working, I'm not going to add it to my data frame. Another thing we can do is arrange our data so it's easier for us to absorb. And you can do this by using this arrange verb. So arrange allows us to look at our data in different ways depending on a specific variable. In this case, our scenario variable. This is akin to being in Excel and saying you want to sort your data from A to Z. And we're using the descending because we want all of our data to come in descending order. If we do this, we now see that all of the highest scenario values are on top. So filter is another one of my favorite verbs. It allows us to subset our data based on multiple criteria. So something that's important to know is that in R, using the and sign means and, so it'll need someone to have both gender equals F and scenarios greater than 3, or this is the or sign in R, scenario equals 1. And if I haven't already made this clear, one thing that is important in R is that for characters, characters need to be wrapped in quotations in order for R to realize that this is a character, whereas numbers can be just represented as themselves. We filter this. We can again check that to make sure we don't have any scenarios that are 2 or 3. and that we don't have any men in our data. We can also use case when to create new variables. So case when will live inside mutate, which as a reminder is what we use to create a new variable. So again, we'll create our new variable, and then after the equal sign, rather than doing a mean like we did above, or just scenario equals 1, we tell it the different situations that should lead to a new level. So to make that concrete, if we want to create low, medium, high levels for our scenario variable, we can actually tell R, okay, anything when scenario is a 2, let's call that medium. If scenario is less than or equal to 3, let's say that's low. And if scenario is greater than 3, let's call this high. The reason I put it in this kind of unintuitive order, namely, we're starting with this equals 2, and then we're doing less than or equal to 3, which also includes 2, is to show you how case when works. Case when, it's going to run all of the lines sequentially. So it's going to first look in your data to see, is there anything where scenario is equal to 2? If so, let's name it MED. Then, once it's done searching through all of the data, it's going to go to the next line. Scenario is less than or equal to 3. I want to assign all of that data within this variable to low. Now, if it weren't sequentially, then what would happen is R would be pretty confused about where to put this data. So when you're using something like case when, it's important to put the most inclusive levels later on, because otherwise they are going, if they happen early on, they're going to assign all of the data to that level. And things like this equals 2 is going to get lost in these less than or equal to 3. Of course, in this case, we could have just said less than 2, and we wouldn't have run into this issue, but I just wanted to include this for the purposes of showing you how this works. And again, always check your work. Select the old variables that contributed to the new variables and make sure that it's making sense. So we can see that everything that's labeled 4 through 7 is high, things that are labeled low are low, so it looks good. If you wanted to do this in a little bit more depth, what you would do is, again, perhaps arrange your data based on descending order. You could also summarize the data further, but for now, let's keep moving. Okay, now that we have dipped our toes into dplyr, I just want to quickly run back to the PowerPoint and just show you that already we've talked about this grammar. You now know how to use dplyr, how to combine different verbs, and we've talked about mutate, we've talked about group by, we've talked about select, we've talked about filter, and I just hope that you have the confidence to try out new verbs based on this spreadsheet that or not spreadsheet, cheat sheet that I showed you, because once you do have a sense of how it works, the functionality really skyrockets quickly. Something I'm doing recently is I'm actually using group by and summarize, and I'm including const, so I'm able to compute a ton of effect sizes, which would have taken me a million years if I just had to run one samples const a million times. So I urge you, please explore, see what works for you. All right, we're at the last part, writing concise code. In the beginning, we talked a little bit about conventions, what makes code look good, but something that is also important is writing concise code. Now, if you're just starting out, definitely don't worry about how many lines of code you're writing. But once you're doing something over and over again, you don't want to have thousands of lines. It's just hard for you to manage. So writing code in a concise way makes it easier for people to look at your code and also easier for you to maintain, spot errors, things like that. So I'm going to tell you about 2 ways to help make your code more concise. The first is for loops, and the second is functions. Imagine you have to run a similar line of code multiple times. For instance, creating the mean of a scenario. You could write a similar line of code 7 times. So just like we filtered for male, female, we're now swapping gender with scenario. We could compute the mean
for every single scenario. But we can already see that this is getting really, really repetitive. Another option is just to write a for loop. A for loop allows you to iterate or run the same line of code over and over again on a specified set of values a specified number of times. Specifically, for loops have two primary inputs, a variable and a vector. The variable is what in order to represent variable, people tend to use the letter I in place of the word variable, but I is really just a placeholder. So when we have 7 different scenarios, I can represent the numbers 1 through 7. This is already more concise because we don't have to write 1, 2, 3, 4, 5, 6, 7, because we can just write I. The vector argument, on the other hand, tells us what values I should represent. Let's make this more concrete with an example. What I've written here is for I in 1 to 3, print I. Now, what I'm doing is my variable or my placeholder is just the letter I, and my vector is 1 to 3. For I in 1 to 3, print I. Now, let's walk through what we've done. We've told R that I should represent 1, 2, and 3. And the reason we know this is because if I just run this section, I see that it's 1 to 3. So again, we use this the colon to represent multiple numbers. And then what we want to do is we want to print the letter I. The reason this is a for loop is because it's saying for all of the different values that I could be, I want to print them. And this can be contrasted with going ahead and actually doing printing 1, printing 2, printing 3, which is essentially what R is doing internally. But I isn't restricted to representing numbers. Rather than saying 1 to 3, we can also use our concatenate to say cats and dogs. And again, if we print I, so nothing is changing inside our for loop, we now see that we're seeing cats and dogs. And like I said, I is just a placeholder. We can replace it with any letter and get the same result. So we can change to Q, for example, and now we're seeing cats and dogs. But let's return to our example, computing a mean for each scenario. The first thing we need to do is figure out what I should be. Should be lowercase, sorry. So we could just write for I in 1 to 7. But the problem is that this code isn't flexible. If we need to drop or add a level of scenario, our for loop might not work. To prevent this, we can use the data itself to specify the number of levels. One way of using this is using Ndistinct, which is something that comes in the dplyr package and tells us how many distinct levels there are for either a data frame or, in this case, a specific variable. Of course, this matches on to what we saw earlier, but rather than specifying, we can just write I, and I'll show you that this works. So let's first compute the mean of scenario 1. Now let's use the letter I, but let's make I 1 so we can make sure the values are the same. And here we've swapped 1 with I. Now we see that we're getting the exact same value, 175.90. So to put it all together, we're now using 1 to Ndistinct politeness scenario, which is what we figured out up here as a way to find the number of unique levels. And now instead of filtering, which we did earlier for a specific scenario, we're just going to use the letter I. We print this, we see that we only see the letter I. Because we've added print I, which tells you to print all of the different I's that the for loop used, I can see that R is iterated through all of the values. But where did all the means go? Again, we didn't save them or assign them anywhere because we didn't tell R where to save our data within the for loop. So the way that you do this is identical to what you would do outside of a for loop, except that we would want to first initialize whatever object. That just means it's going to become some sort of empty object or value
Sometimes if you know what you want this to be ahead of time, if you want it to be a list, you can specifically make this a list, for example, by writing list. Do a similar thing with vector. But for now, let's just initialize it by making it empty. Now, the only thing we've changed is added this save here. When we call this, we can look at save here, but now we only see one value. What's happening? If you were to look at all of the means for the different scenarios, you'd figure out that we're only saving the last value. This is because, unlike when we're outside of our for loop, but we can save every value by adding a new argument, which is this bracket I. And what this is doing is it's allowing save here, which is our new object, to take different means from different scenarios. And if we do that, we can see that now we have, 7 values. However, if you don't want to save the values, but you want to look at them, you can also just print the values directly. Note that this code works because our variable had the levels 1 through 7. What happens if we want only the levels 1, 5, and 7, or our variable wasn't an integer? It was 1.5, 2.7, etc. To compute the first case, namely if we only want 1, 5, and 7, we can go ahead and specify the levels specifically. So we can again initiate our object. And now that we can see that we only have the first, fifth, and 7 levels. Alternatively, we can grab the level names or specific levels of the variable. Alternatively, we can use levels to grab the levels of a variable. And this is really handy if you have factors, character variables, or have inconsistent or missing levels. Note, this doesn't work automatically with numeric variables. So again, we'll get this null value, but like we did before, we can add this add factor argument and now get all of the levels. Now we can use this levels. Now we can grab this and use it as our vector, and nothing is changing. So now we can see that we have the same results as our initial save here. The only addition is that we now have this numbered because we're drawing it from the levels of the variable rather than using I, that's just a vector. We can also layer or nest for loops. So we, for example, can have one for loop and then have another one where we have a different type of variable. We can go ahead and run this line of code and see we have printing 1 through 7 as well as A and B. Note that you can't just add a comma. They do need to be variable vector in a single for loop. So you can go ahead and basically do this by writing for, and then after the first bracket, press enter, and then write for again. And now you'll have 2 for loops and your code will be inside both of them if relevant. Finally, something I'll mention is that if you're familiar with Python, you should note that R is not sensitive to white space. So this really wacky line of code will still run even though there's a ton of white space and it makes no sense. However, something like this would not run in Python. All right, so we've covered for loops, which are helpful if you want to run code over iterations of a variable. But what if you want to run a series of code over a variable? For example, computing the mean and then computing the standard deviation and then subtracting the standard deviation from that mean. Writing a function will allow you to write the series of code once and then apply it whenever it is useful. Unlike for loops, functions don't need a variable and a vector argument. They're totally flexible. All you need to do is give the function a name and tell it which variables or variable you're going to manipulate. You can name the function anything, and just like what you put as in your variables argument is just a placeholder. So you can name it Bahamas even if you and your dataset are nowhere close to a tropical island. Now, the important part is to slot your variable, for example, Bahamas, into where it will be relevant. So if we want to compute the mean, standard deviation, and then the mean subtracted by the standard deviation of our variable frequency, we need to swap the variable frequency with Bahamas. The reason we do this is because we might want to compute the same series of code on other variables, not just frequency. By using Bahamas as a placeholder, it allows us to be totally flexible in how we use our function. So let's go ahead. What we've done here is I've already kind of showed you we have the variable name and our dummy variable. And so what we have here is we have our function name, the variables we want to manipulate, and inside of it, we are computing the mean, standard deviation, and then subtracting this to create this final data frame. Now, note again that we've included this dummy data frame. I don't even have anything in my environment called Bahamas, besides it's in the function. However, by using this placeholder, like I said, we can compute this series, mean, standard deviation, mean divided by standard deviation, on any variable. And to run our function, we simply use our function name, and then in parens, the variable in our real data set we want to use. So in our case, I'm doing politeness clean with frequency. If I run this, we don't see anything. Nothing here. Why is that? Okay, here it's because we again didn't save the output. We ran it, but we didn't save it anywhere. So if I assign this to saved output, we now see that we have the data. And if I were to do this for something similar, let's try a scenario, we see that we get a different value. And the only thing we've changed is this variable here. We didn't have to go through and run all these lines of code for a different variable. Finally, you might want to nest a for loop within a function or vice versa. And we might want to do this if we wanted to run our function over every scenario, for example. So here, we would again use our for I in levels. And then the only thing we would do is actually insert our function within this for loop. So this should look familiar. We have funky fun and our politeness clean. The only thing we're adding is we're actually using this filter for equals to I. And what this is doing is, again, just to remind you, it's for each of the I in the levels of the scenario, we're going to run this line of code. And let me just show you. So now we see that we have used this function to create this mean minus standard deviation for every single one of the 7 scenarios. And just to make this super clear, what we've done is we have the for loop, which is just running all of the different, taking I to represent all of the levels. And what you probably just noticed is that I forgot a paren. And one way you can check your paren really easily is you actually hover over your parens and you can find if there's one missing, for example, like this one is when I go to the right of it, nothing's popping up, so I would delete it. So for I in 1 to 7, we're just filtering scenario and then using our function to compute those 3 things on the single variable. All right, so in the examples above, we've been using for loops and functions. These are very useful. However, when you just need to summarize data like we're doing here, there are other options. You could have used group by and summarize like we did earlier. And if you didn't fall in love with dplyr, you can also use plyr and the dply function. So again, we can look at this like this. All right, that was a lot of information. Thank you for bearing with me. I just want to remind you that there are also other resources related to this topic. Feel free to rewatch the video. Feel free to go through the R script on your own. I've also included exercises to help you apply and extend your knowledge and the cheat sheets we used during this course. All right, I hope this was helpful. I know that it will take a little bit of time to digest all of this, but I promise it will be so worth it.